Today, we will evaluate the performance of RAG systems. Now, we build RAG systems to leverage LLMs to work with our own private data and the data which the LLM models has not been trained on. Okay. So at a very high level, in a RAG system, we build a retriever and then use a generator to synthesize an answer. Now, we start with our own private documents. First, we chunk them into smaller documents. That's based on the context length and the token limit of the LLMs. Okay. And then we use an LLM model to create the embeddings. We call this retriever. I'll explain why that is. And then we store these vector embeddings in a vector database. Okay, that's step number one. And then in step number two, when we ask a question, we use the same LLM to create the embeddings, and we use this vector semantic similar search to extract the documents similar to our question. So this LLM, it retrieve documents which are similar or relevant to our question from this very large vector database. Okay, so that's why it is called retriever. Now let's think, why do we even need this retriever? I mean, why can't we just give our whole document as a context to an LLM? So there are two reasons, right? One, the LLMs have a context length, but the recent one, the context is increased up to 1 million or even higher, right? So we can input a large book as well as the context. But the issue is the performance is not as great. The reason is, if we provide a smaller piece of context which is relevant to our question, then the LLMs are performing better. Whereas if we provide a very large context with the answer relevant to our question is somewhere buried in the middle, then the LLMs are not able to extract the right answer. Okay. So for that reason, we want to provide the LLM only the right and the relevant context, not all the unnecessary information. Okay. So that's the reason why we need to build a retriever, so that from our large corpus of documents, we will be able to extract the relevant parts and provide them to the generator. Okay. So in step number one, as I mentioned, to our question, we have extracted the relevant documents. And in step number two, where we use this generator, right? So we simply provide the question and these documents in the form of context to this generator LLM, which provide the answer. Now these two LLMs, they can be the same, they can be different, but in general, we will use a model which is created or fine-tuned to give better embeddings as the retriever. Okay. And for generator, we can use more of a general purpose LLM, because it is simply synthesizing the context to answer our question. Okay. Basically, that's a very high level description of RAG system. Now, what are the evaluation metrics? So as we just discussed, we have two main components. One is retriever and one is generator. So we want to evaluate the performance of a retriever and the performance of a generator. Now for each one, we have two metrics. Okay. So for retriever, we have context precision and context recall. Now, these two are similar to how a precision and recall are in a classification case. So the precision is simply when the retriever extract these context documents, how correct are they? Okay. So it's easy to understand using what goes in as an input, right? So in this system, we have four variables, right? One is the question, this one, and second one is the retrieved context, these two documents by the retriever, and then the final answer. So here we don't have ground truth, but let's say we have manually annotated the questions to have the ground truth. Okay. So these are the four variables. Now the context precision, it takes the question and the retrieved context. So the question and the retrieved context as an input. So what it does is it evaluate how relevant these retrieved documents are to the question. Okay, that's context precision. And then the context recall is, because this is a very large vector database, meaning very large chunks of data, is the retrieval able to retrieve or recall the correct documents needed to answer this question? Okay, provided the vector database actually has the relevant documents. So it's recall or retrieve. Okay, so it takes the ground truth and the retrieved context, because the ground truth is to know if the retrieved documents are relevant, right? We need to know the ground truth. Then only we will be able to say if these extracted documents are useful or not at all, right? So the context recall is simply, is the retriever able to retrieve the relevant context documents from the vector database? Okay, so that's the context recall. And then we have two metrics called faithfulness and answer relevancy relevant to the generator. So first let's look at the relevancy, which is easier to understand. So it takes the question and answer as an input. So it takes the question and an answer. So it's simply, the metric is simply to measure how relevant the retrieved answer is to the question. Okay, so how relevant the retrieved answer is to the question, synthesized by the generator. Okay, and then context precision, the faithfulness, it takes the answer and retrieved context as an input. So the answer and this retrieved context. Now the way it works is, based on the answer extracted, we will generate a bunch of statements. Okay, and we will verify if those statements can also be verified against this retrieved context. Okay, so it's like how factually accurate the generated answer is. Okay, so from the generated answer we derive some facts and we verify if those facts can be derived from the retrieved context. Okay, so that's the faithfulness. Now if we were comparing two numeric numbers, it is super easy, right? Because we can say which number is smaller, which number is higher, what percentage difference, how much is the absolute difference. So comparing two numbers is super easy. But here what we have is four pieces of text, right? This answer, retrieved context, question, context, answer, and ground truth, which can be very subjective, right? Because if you provide this context to a human and you ask different humans the same question, they will answer it differently, right? So here the ground truth is also subjective and it can vary. So we are comparing a text to a text, right? Which is quite difficult to do. So interestingly, we use LLMs to evaluate or measure these metrics. So basically what we do is we tell an LLM, hey, your role is a teacher, for example, assessing the student's answer sheet. Okay, so here is the question, here is the relevant document, this is what the student answer is. Now you evaluate if this answer is correct and you give a score between 0 to 1. Okay, so that's how we design the prompt so that an LLM can give a score between 0 to 1 for all these four metrics. Okay, so there also a bit of subjectivity in addition to this ground truth, because when we use a different LLM, it will provide a slightly different answer, right? So there is subjectivity from ground truth, subjectivity from what LLM we use. Okay, so that's what make it quite challenging compared to comparing two numeric numbers. Okay, so let's start. So I don't want to make this video too long, but I have covered all the code and what the RAG systems, etc. are in much more detail in other videos, which I provide the link in the description below. But quickly, we will look at the solution. Okay, So first we want to collect the documents, right? So first we want, in this diagram it is not shown, but let's assume here we have our very large corpus of documents. Okay, we want to collect the documents. So here we are simply downloading this State of the Union speech from the President of United States from this Git repo. It basically the speech by the president on politics, economy, so on and so forth, so many other things, right? So this is our extracted doc. As you can see, it's a very long piece of text. Okay, and then we chunk or split the document into much smaller pieces. Okay, so we are using this character text splitter, and we are dividing this into chunks of 500 tokens, and with an overlap of 50, so that the continuity is maintained. Okay, so here it is divided into 90 chunks. Okay, for example, if you look at so this is one chunk, and this is another chunk, etc. Now here this metadata, it can be important. We are not going to use this metadata because we are only looking at a semantic search. But when we build a hybrid search where we can leverage the metadata to filter, right? So that would be more like a lexicon plus semantic hybrid search. Okay, but here we only have the source of the data, right? From where this chunk is coming from. Now it is not necessary that all our document, all our text is coming from one document, right? We can have multiple PDFs, research related documents or manuals, etc., right? So it is important to keep track of the source as well. Okay, so we divide this into chunks, and so this is what we currently have. We have 90 chunks, and then we are going to use an LLM to create the embeddings and put them in a vector store, and then build the retriever. Okay, all right, so we have done the chunking, and then we want to create embeddings, right? So here we are using, we can either use this OpenAI embeddings or this Olama embeddings wrapper from LangChain, so that we can leverage models like Llama 2, Mistral. This is the Gemma 7 billion parameter model released by Google just yesterday. Okay, and for the vector store, we are using this VV8, which is free and open source. There are a number of others like Pinecone, ChromaDB, etc. Everything, they are all quite good, and all those does the job quite well. Okay, so here we are building the vector store. All we need to do is simply provide our 90 chunks and provide an embedding model. Okay, so the vector store, it create embeddings for each chunk and store them in the vector store. Okay, so we have completed this part. Okay, we have completed the vector store. Now we want to build a retriever, meaning something which is able to take a question and extract the relevant documents from this vector database. Okay, so it is just one liner. So here we are building a retriever, and we want to extract the top 3 documents. Okay, so K, the parameter 3, we want to retrieve top 3 documents. So that means whenever we ask a question, the retriever, it extract the top 3 documents from this vector store which are relevant or semantically similar to our question. Okay, so this part is done. Now we are going to build a generator by putting all this together. Okay. Yeah, so to generator, we provide a prompt, right? So we it's like giving a persona to the generator. You are an assistant for a question answering system. Now we'll provide you a piece of context. So you use the context to answer the question. Now, if the context do not have the answer, then simply answer, you don't know. Please don't make up something which is what we call hallucination, right? And again, we can set some, give it some instructions on how long the answer should be. It should be a paragraph or it should be bullet points, so on and so forth, right? So it takes 2 parameters, the question and the context. Okay, so then we design this LangChain prompt template, which takes again those 2 parameters, context and the question. And to generate, we need an LLM, right? So here for the retriever, we used OpenAI embeddings. And for the generator also, we need an LLM. So what we are doing is, so here we have defined the GPT 3.5 from OpenAI. But again, you can leverage this Olama wrapper to work with any other models. For example, if you were to use this Gamma 7 billion parameter, you simply install Olama on your system and download the Gamma model, which is just a one-liner. Once you download, you can use that in your LangChain wrapper. Okay. And here, finally, we are putting all the things together. So we are basically building a pipeline, right? So the retriever, the question, the system prompt for the generator LLM, and parsing the output. Okay. So we build a pipeline, right? Now we can call this pipeline with a question so that it does its job and provide the answer for us. All right. So here we have prepared a few questions, right, relevant to the State of Union document. So, for example, what did the president say about some Justice Brenner? What did he say about Intel CEO? And what did the president say about gun violence? Okay, so these are the questions we want to find answers to from our president's speech. Now, here we have the ground truth, as you can see. So this ground truth is written by a human, right? It's a human annotated. Now, as I mentioned, we don't necessarily need to have one ground truth per question. We can have multiple ground truths. Now, using our RAG system, we want to be able to extract two things for each question. One, obviously, we want to know what the answer, and two, we want to know what the context, the extracted context is, so that we can evaluate our synthesizer or the generator, and we can also evaluate our retriever, which is extracting the context. Okay. So here we are looping over each questions one by one. We are invoking the RAG chain or the pipeline with the query, and we get the answer back. So here we are collecting all our answers. Now, in order to do this, when we invoke the RAG chain, it's first working with retriever and then synthesizer, right? But it provides only the final answer, but we wanted the output from the retriever, right? So in the next step, we are calling only the retriever with our query. Okay. So this retriever gets us the context, and the context we are appending to this variable. Okay. So we have collected the questions and the context to each our question. Now we are going to prepare the data for our evaluation system. So we are going to use a library called Ragas. Now that library, it expects the data in this format, right? A question, an answer, what context is used to answer the question, and this human annotated ground truth. Okay. So for each question, it expects a dictionary in the form of these four elements. So here what we are doing is we are preparing the data in that format. Okay. So we simply prepare the data in that format, and we created a pandas data frame. Okay. Data set. So this is how it looks like. Okay. Maybe I'll show you the data set. Let me see. What did we call? Data set. Yeah, so this is how it looks like, right? So we have a question, answer, context, and ground truth. The number of rows is 3. So this is what we prepared. All right. Now, here we are using only 3 questions, which is not enough to evaluate the performance of any system reliably. But here I have provided a document to a link on Hugging Face. This has about a dozen other questions. Okay. So if you want to evaluate your system, include these answers as well. Sorry, these questions as well. Okay. Finally, the evaluation. Now we are using this library called Ragas. It's a simple pip install. So import the evaluate, and we want to evaluate these 4 metrics: context, precision, and recall, the faithfulness, and answer relevancy. And when you call evaluate, simply provide the data set and what metrics we want to measure. So this data set is in this particular format. Okay. Now by default, Ragas uses OpenAI LLM, but again, if we want our own custom, use our own custom or some other free LLM, we are free to do so. Okay, either it can be Olama or VLama or Llama Studio. You just need to provide the endpoint. Okay, all right. Here we are looking at the result. So this will evaluate and provide the result. Now it will provide the overall result for all the questions, right? So here we are looking at the context precision 1. The context recall is also 1. The faithfulness. So this is the average over all the questions. So faithfulness 0.8 and the relevance is 0.6. Now it seems like our retriever is doing quite well because the two metrics, the precision and recall relevant to the retriever, are spot on. Now our generator seem to be doing as well, but again notice that the generator uses ground truth, right, which is a subjective, right? So whoever wrote this answer, that answer can be a very subjective, right? So maybe if some other person wrote that answer in a different way, when we compare, we may have these better results for our generator. Okay, for example, I'll show you here. So this is our first question, right? What did the president say about the Justice Brainer? Now this is the extracted answer. Okay, so this is the extracted answer, which is correct because this is not too complex task. So the president honored this person with service and dedication to the country. He mentioned nominating blah blah blah. Jackson question Justice Brainer, legacy of excellence, so and so forth, right? But our ground truth simply says this. Okay, our ground truth is so short and on spot, whereas the extracted answer, it also talked about this Jed Kennedy Brown, etc. Right? So that's why our generator score are a bit low. Okay, our generator scores are a bit low, whereas our retriever, which is simply extracted this context. So if you look at the context, because it is extracting 3 context per question, so what happens is, if these 3 contexts have answer to the question, then we get better results for the context precision and recall. Okay, so I'm not going to read all this text, but you can examine these questions one by one. So have a look at the question, what our ground truth is, and then the extracted context, and then the answer. Okay, so that's all for this video. I'll thank you very much.